Okay. Next video on sampling distribution. This time we will focus on our the sampling distribution of our mean. Okay, so suppose that our sample mean is the mean of an SRS, or X bar, I should say. So suppose that X bar is the mean of an SRS of size n, drawn from a large population with mean mu and standard deviation sigma. Then the mean of the sampling distribution is just going to be your mu. Okay, and the standard deviation of the sampling distribution of X bar is going to be as follows. Now, this will be better explained in your textbook on page 456 in the math box, if you want to know where that comes from. Okay, you can only use this as your standard deviation as long as the 10% condition is satisfied, so you need independence there. Okay. So these facts about the mean and standard deviation of your sample mean are true no matter what the shape of the population distribution has. So this means that you do not have to check the large counts condition to be able to use a normal approximation. So it will be, your sampling distribution will be normal no matter what size the sample is. So we'll talk more about that in the last video. Okay, so let's take a look at an example of how we can find our mean and standard deviation. Sulfur compounds such as DMS are sometimes present in wine. DMS causes off odors in wine, so winemakers want to know the odor threshold, the lowest concentration of DMS that the human nose can detect. Extensive studies have found that the DMS odor threshold of adults follows a distribution of 25 micrograms per liter and standard deviation of 7 micrograms per liter. Suppose we take a simple random sample of 10 adults and determine the mean odor threshold X for the individuals in the sample. So your mean is going to be quite simply the 25 micrograms per liter. Okay. For your standard deviation, it says to check this. Your questions won't say that. You have to know that to be able to use this as your standard deviation, you have to be able to, you have to have them be independent. You have to check your 10% condition. So it's fairly easy, though, to realize it here. 10 adults is definitely within your 10% of your adult population. So you can assume independence and you can use the standard deviation as follows. Okay, so your standard deviation, they told you, was 7. Your sample size here, 10. That would give you a standard deviation of 2.214. Okay. So now let's take a look at some examples that follow normal distribution. So the height of young women follows a normal distribution with mean 64.5 inches and a standard deviation of 2.5 inches. Okay. So there's no need to. Okay. So we're going to say let X equal the height of young women. Randomly selected young women. It was weird. Okay. We know it's a normal distribution with a mean of 64.5 and a standard deviation of 2.5. Okay. We are looking for the probability that it will be more than 66.5 inches, or a randomly selected woman will have a height of more than 66.5 inches. So our quick sketch Here's our mean at 64.5, okay? We are looking for our area under that part of the curve. So, because we know it's a normal distribution, we can use norm CDF. I ran out of room, so I'm going to continue over here. Of your lower boundary here, 66.5. Your upper boundary, I'm going to use 1,000. Your mean of 64.5. Your standard deviation, 2.5. Okay, and so we would have about 21.2%. So how we can interpret this would be the probability of choosing a young woman at random whose height would be over 66.5 inches would be 21.2%. Okay, so now let's take a look when we have a simple random sample of that population. So now the height, the same holds true, okay? But now we want to find the probability that the mean height of an SRS of 10. So that's going to tell us that it's a sample mean of the woman would exceed 66.5 inches, okay? So one thing's not going to change is the mean, okay? Your standard deviation, however, will, okay? Because now you are dealing with your sample of 10. So now our standard deviation is 2.5 with a sample of 10. That's going to give you a standard deviation of 0.79. Okay, so we have a normal approximation, the mean of 64.5. This time our standard deviation 0.79. We're looking for the probability that our sample mean will be over 66.5. Okay, our sketch will be a little tighter, but same area under the curve, or same location, okay? And so we can use norm CDF again, and same boundaries. Oh, it wasn't 64, it was 66.5. I ran out of room. But our standard deviation is much different, okay? So if you have a standard deviation of 0.79, you're obviously closer together. So if my next slide will show the difference. So for the population, I would have had, my curve would have been not so tight together because your standard deviation was 2.2 something, 0.219, okay? So it would have been stretched out slightly different. I have it in the next slide. So, oh, I didn't put down the answer, sorry. So your answer here, 0.0057. So that would show you that it is very unlikely that you would choose an SRS of 10 randomly chosen young women whose average height would be greater than 66.5. Here's the normal curve that I was saying. So tighter together for your sampling distribution. And that's it for this video.